function of x. So first of all, the nice easy one is the first one. What's the derivative of x cubed?
3x squared.
Yes, 3x squared. And what's dx over dx? Well, the derivative of just x is 1. Dx over dx right here is just 1. That's why it's 3x squared right there. What do you have to do here, though? What do you have to do for y cubed? That's the same thing as f of x cubed. So when you take the derivative of that, like this, what do you drop to the front? What do you drop to the front? 3. And then what does the power become? Becomes 2, but then you have to use the chain rule and multiply by the derivative. So in that case, do you have that right there? Yeah. Let's take a look at that. You have 3f of x squared. Well, that's 3y squared.
Mr. Seaman, what is the dx over...
Hold on. Let's just finish this part first here. And then you have f prime and f prime. Dx over dx is the invisible 1. There's a lot of 1's that we've had in here. Dx over dx is the derivative of x. What's the derivative of x with respect to x? 1. Dx over dx is how you would write it. We haven't been writing it in because there's tons of invisible 1's all over the place.
So dx over dx
is 1. That's just the derivative. You don't have to write that in. I'm not going to make you write that in. You don't have to write in dx over dx. You do not have to write dx over dx. That's fine. You can just write if you're doing the derivative with respect to x of x cubed, just make it 3x squared. Yes, Henry. All on one side. We put it all on one side. And then, Jen, you gave me the answer to this yesterday. What do you do to get from here to here? What did we do to factor? Exactly. We factor. So where did the oh, now there's one of them, right? So now what can we divide by? We can divide by this thing. Exactly. Exactly. Kids, if you had stopped right here, I'd be totally okay with that. That's fine. You could factor out the 3's if you want to. You could. Thank you. Plus 3y squared y prime equals 6. And this is how I would write it out. xy, you have to use the product rule, right, Zach? What's the derivative of x with respect to x? 1. So you have 1 times y plus xy prime. It's the exact same thing as what was written over on the left with slightly different notation. That's it. What am I isolating again, though? What am I isolating now? Y prime. There it is. Yes, Connor. Plus y cubed is equal to 6xy. I see this all the time. 3x squared plus 3y squared is equal to 6y. Is that correct? No. Why not? Because you have to treat y as a function of x. The reason I want you to put in f of x for y is it forces you, I think, more directly to use the chain rule. What's missing here? Like what goes right there? A y prime, right? And then over here, you just totally miss the product rule. Right? So it's really easy to do these wrong, not because you don't know how to do it, but because you just miss a step. So yeah, so you can plug it in and immediately plug it back to y. That's fine. I just really like it written like this, because if you write it like this, Nick, what are you much more likely to do? Equals 6x times f of x. You're much more likely to use the chain rule and the product rule and not forget it. Okay. And what rule do you have to use right here? Kira, what rule do you have to use on x times y? What rule do you have to use right there? Yeah, that's the product rule. So where's the derivative there? There it is. That's the derivative of x times y. What's the derivative of x with respect to x? 1. And what's the derivative of y with respect to x? Well, dy dx. So at this point, this is, from here, it's calculus, and then what's after this? To here, what is that? What type of math? Algebra. That's right.
So an x in this situation is...
The derivative of the first times the second plus the first times the derivative of the second. That's what that would be written out. Yes. There you go. And what's another way to write 1? That's also, as Nick pointed out, that is dx over dx. That's the same thing. But again, Nick, do you have to write dx? No.
No.
You do not have to.
And you don't have to write dy over dx?
No, you could write it as y prime if you wanted to. You could write this is the same thing as y prime. That's fine. But you have to know, because some problems are going to write dy dx, and you have to know that that's derivative. You have to know that. Right here, what rule do you have to use right there? What rule is that? Product rule. That's the product rule. You have x and ln y. What's the derivative? Oh, and this is the key here. What is the derivative of ln y? Times what?
Y prime.
Times y prime. Because y is a function of what? X. Y is a function of x. The derivative of ln y is 1 over y prime. It's harder to see that. What did I have you do before? What was that first step that I've drilled into? I've tried to get you to do. Ln y is the same thing as ln of what? F of x If you see ln of f of x, what are you more likely to do if I ask you to take the derivative?
Take the derivative of the inside.
Yes, not forget that. If you do the derivative, you have 1 over f of x times what? F prime of x. And now what can you substitute back in? Y. It's the same thing. What is the most common way to get these wrong? To forget the chain rule, to forget the product rule. If you don't use those rules, you will not get that correct. How does this one feel to you right now? Just the one that's on the board right now. The x of ln x. What's the definition, kids? I really don't want to have a conversation with myself. You know this. What is the derivative of ln x?
1 over x.
Yeah. And what's the invisible thing that it's multiplied by? 1. Dx over dx, 1. Dx over dx is 1. Dy over dx is not 1. Dy over dx is the change in y over the change in x, which is the same thing as y prime, which is the same thing as f prime of x. It's slope, the slope of the tangent line.
Or
Instantaneous rate of change. Correct.
So then what's d over dx?
D over dx means take the derivative in terms of x. That means take the derivative in terms of x. It hasn't been done yet.
Okay.
It hasn't been done yet.